All right, folks, we are back again. Welcome to another episode of The Binding Status. I appreciate everyone coming out today. I know that there's a lot of uncertain times still, like last time we did the show. So I hope everyone is safe and well. It's great to have you here. And like usual, we're going to try and keep it casual and just kind of explore some really cool technologies that are nice to work with together. So please feel free to drop your name in the chat and we'll make sure to give you a shout out. Let us know where you're joining from. Let us know what you're up to. As we go along through different demos and that sort of thing, please feel free to ask questions or provide comments and that sort of thing. And we'll try to address them regularly throughout the show. So as you probably know, my name is Dan. I'm a software engineer. I work on the CrossPlane project and also work on the Kubernetes release team. And we do this show every other week, and we try to have a guest on from a project that we think integrates well with CrossPlane. And today, I think we have a project that integrates really well with CrossPlane. So I'm excited to get into it. And I am joined by Torin from over at Open Policy Agent. He is the co-creator and maintainer of the project, which has grown quite a bit over time. And I'm going to let him tell you a little bit about that. But yeah, we're really excited to have him on. And Torin, feel free to give yourself an introduction and mention anything else that you'd like to.
Yeah, so I'm Torin. I am one of the co-creators and core maintainers of Open Policy Agent today. So yeah, I spend most of my time working on Open Policy Agent from a company called Styra. We are the sort of creators of the project, and we created the project about 4 years ago, and then eventually we ended up donating it to the CNCF, and I've been sort of I've really enjoyed working on OPA for the last almost 5 years now. Being able to work in open source has been tremendously rewarding, I think, as a developer who spent like most of their career as sort of like a dark matter engineer, just kind of like programming for some company, behind the scenes and never really, going out into the world and talking to users and so on. So yeah, it's been extremely rewarding. And one of the things I love about it is just being able to talk to users and talk to partners and so on and see how it was getting used. So that's why I'm kind of excited about this stream, is because it's always cool to see a new a new use case or a new kind of integration with OPA. So super happy to be here.
Awesome. Well, we're happy to have you. And I wanted to recognize some people in the chat real quick. Looks like we have Marcus, who joins regularly. He is in New Jersey. I know that, even though he didn't mention it. And we're actually chatting this morning about some use cases of OPA with CrossPlane. So I'm excited to see him here. We have Phil from Seattle. Thanks for joining, Phil. He also works on the CrossPlane project. Jared, who's one of the founders of the CrossPlane project, is joining from San Diego. Steven from St. Louis. All right, this is probably the first time we've had another St. Louis person pop up in the chat. So good to see you, Steven. And then it looks like Yoan, I apologize if I'm getting your name wrong, but joining from France. Thank you so much for tuning in. And let's go ahead and get started. So as usual, we're going to start with a bit of an overview of Open Policy Agent. So we usually structure this where I'm going to kind of look through the docs and ask Torin questions, and he's just going to give us some insight on what we're looking at and provide any context around the project. So I'll go ahead and get my screen sharing here. And we're here on the Open Policy Agent main page. One of the things that jumps out to me immediately, Torin, is that Open Policy Agent is meant to be run across all kinds of different stacks. So the policy language is not specific to Kubernetes or anything like that. And it even mentions a couple of different integrations here, as well as running it as a library or a daemon. So could you talk a little bit about that and kind of the flexibility of the model and generally how you mostly see people implementing Open Policy Agent across their stacks?
Yeah, for sure. So I mean, I guess just at a super high level, the goal of the project is to provide basically a tool or a building block that allows large organizations or any organization to unify policy enforcement across a wide range of software. And sort of the thesis, the reason we started the project in the first place was because if you talk to most companies or most large organizations, they'll tell you that they have 50 different ways of controlling who can do what across their stack, right? So whether you're talking about orchestration platforms or microservices or the data layer or anything like that, each of these different layers, each of these projects, each of these products typically has its own way of expressing and enforcing policy, and that fragmentation makes it really difficult to control policy, to control who can do what, as well as to understand who can do what across the system. And so, what we think is a better solution, or what we think that requires a rethink. And so, we think that a better solution is to have a single way of expressing authorization and more generally just policy across the stack. And so that's done with OPA's language, and we've sort of, because we want to have it applied across the stack, we made a bunch of design decisions to keep it as kind of loosely coupled as possible to different pieces of technology. So yeah, it's not tightly coupled to Kubernetes in any way. We do have integrations with Kubernetes, and we have integrations with Envoy, and we even have integrations with like Linux PAM if you want to use OPA to control access at inside of SSH and sudo. But on its own, OPA is totally general purpose and completely domain agnostic. So we find it serves as an excellent building block for policy and authorization.
Yeah, that's awesome. One of the things we talk a lot about in CrossPlane is the benefits we get from standardizing on the Kubernetes API. So y'all have kind of done that in a different way, right? Because you standardize through integrations with Kubernetes, and we can kind of get all these benefits. But it's also nice if someone coming to CrossPlane who wants to use OPA, maybe they have not used Kubernetes before, or they've used, they're just running servers themselves or something like that. And they could have already had experience with OPA and automatically know how to implement policy using CrossPlane. So that's definitely a really cool thing. And that flexibility in your design decisions around that seem to have gone a long way in enabling users. Stepping back a moment, kind of before we dive deeply into how OPA works, could you talk a little bit about the project? You are one of the co-creators of it, and it's been around for a little bit now. Could you talk a little bit why it was started, when it was started, and what was the motivation and how that's changed over time?
Yeah, so the goal of the project hasn't really changed at all since the beginning. The reason why we started it was that we talked to people at, for example, like large financial institutions, right? And they expressed not only that problem with like heterogeneity, right? Like all these different ways of controlling who can do what and controlling policy existing in the systems that they have to manage. But they also described the challenges of taking older legacy policy and authorization systems and trying to apply them inside of the cloud or inside of cloud native sort of technologies or systems. And one of the big challenges that you run into if you try to apply some of the more kind of like legacy technologies is that they tend to be overly centralized, and therefore they don't really work well in kind of these modern distributed environments that are highly ephemeral, right? You have workloads that are coming and going, on the order of minutes, but potentially, they're running across multiple clouds, they're running on-prem, they're running in the cloud, and it just doesn't really work to have everything calling back to some central server that's running inside of the data center that you built, 10 or 15 years ago. So the combination of this like heterogeneity problem of having too many different ways of saying, this user should be allowed to do this thing in the system, and like the kind of inherent scalability and management challenges posed by cloud native systems kind of necessitated a rethink for policy and authorization. So that's why we created the project, and that's why the company was started, to kind of address that. So that's sort of where it came out of. And then I guess like over the last couple of years, I guess like any project for the first 2 years or first year or so, we were just really focused on the core kind of like our development of the project. And then we started to take it and integrate it with different projects. And one of the ones that we looked at was Kubernetes. And we found the admission control use case to be a really good fit. And so over time, admission control and config validation in general have become a dominant use case for OPA. We see, there are hundreds or thousands of people running it for admission control inside of Kubernetes. It's supported inside of the cloud providers like GCP or GKE and AKS. We just saw recently that Rancher has added support for it inside of their distribution. So it's kind of become, it's really picked up a lot of steam for this kind of problem of admission control, and as well as kind of config validation with other systems. Like we see people using it for just generic config validation use cases where you want to put down some guardrails on your configs and have those enforced during like a Git pre-merge hook or within CI. So that's like one broad category of use case that we see is config validation for Kubernetes and other platforms. And then the other broad category of use cases that we see people applying OPA for is kind of like API authorization inside of applications and microservices. And that was one of the earlier use cases that we saw people adopted for. Like we gave a talk with Netflix back in 2017 about how they were leveraging it at the time to do authorization in their microservice environment. And that story, that use case resonated with a lot of people, and over time we've seen a lot of folks adopt OPA for that as well. So we had some good talks at KubeCon in San Diego from like Yelp and Pinterest and Atlassian about how they're doing similar stuff with OPA and Envoy or OPA within a microservice environment. So I guess a lot of this stuff is all driven by like organizations wanting to move faster and provide kind of self-service infrastructure and environments to their developers, while at the same time maintaining a certain amount of security and kind of availability and cost and operational guarantees that are important, obviously.
Awesome. That's super cool. Yeah. And I noticed here that you kind of have like this Kubernetes section and then other use cases section. And obviously the Kubernetes community is one that talks a lot about using OPA and that sort of thing. You mentioned that it wasn't, originally created for that purpose. How soon after the initial creation, or maybe at the time of creation, how much was Kubernetes on your radar? And then like, how have these other communities evolved to use it? We see these other use cases here. Also for folks at home, there's this integrations page, which is pretty interesting as well, which I'd love for you to also provide some color on what the difference between like use cases are versus integrations and how those work. So if you want to touch on that a little bit, that'd be awesome.
Yeah. So I guess Kubernetes came onto our radar. I mean, it was already on our radar before the project. I think the company we even started, I think a bunch of us had been looking at, different kind of orchestration platforms, because that seemed to be like what where the market was kind of moving. And then Kubernetes, we did early on, we did a bunch of investigation to see, well, should we integrate OPA with like Docker Swarm or with Mesos Marathon or Kubernetes? And we ended up picking kind of Kubernetes as the one to focus on initially, and I think that paid off. And so so after the first, I don't know, 3 or 4 months after starting the project, we started to take it and try to integrate it with different things. And Kubernetes was the first one we picked. And actually, like when we started off with Kubernetes, we weren't looking at admission control. We were looking at scheduling, like how pods get scheduled onto nodes. And so the first kind of real policy that we wrote for OPA basically was a port of the upstream Kubernetes scheduler into Rego. So we took all of the filters and weights that are like implemented in Go, and we tried porting them over to Rego to see, if we could do it, like whether the language was going to be able to do it or not. We thought it would, but we just wanted to test it out with a real use case, and then B, what the performance was like. And we got pretty far. We were able to port like all of the filters over, I think, at the time. And then there were a bunch of weights that we tried, but we ran into some like performance issues pretty quickly with some of the weighting functions. And what we learned was that like OPA is really, at the time, it was really good at that kind of filtering function of saying, okay, like this workload or this pod or this container can run on like these nodes, but it can't run on those other nodes. But then when it actually came to spreading the containers across different nodes in order to like, meet some cost guarantee or some cost constraint or something like that, it wasn't really a good fit at the time. It still isn't really. So we kind of backed off that, and we started looking at other use cases within Kubernetes, and we played around with just API authorization, because at the time role-based access control hadn't yet. This was like 2016, so role-based access control wasn't really there. We looked at federation as well. So when the federation, like V1 of federation was around, we actually got OPA upstreamed into federation to do policy-based placement, which was kind of similar to that scheduling thing, but it was just the filtering function. And then we ended up finding admission control. We ended up like, what I used to do is just like go to a project and type policy into the GitHub issues, and then see like what would come back. And like if you did that in Kubernetes at the time, you would see a lot of like admission control related stuff, like, oh, we want to restrict what container registries can be used, or we want to require certain labels, or we want to ensure that CPU and memory limits are supplied. And there were some solutions at the time, like there used to be like an image policy webhook, I think, inside of Kubernetes that would allow you to like configure a policy just on the image of a container, and it was sort of like hard coded to do that. And so we looked at that and took it as kind of inspiration that this was a problem that people wanted to see solved, and so we started kind of like building out little integrations, and eventually I think as like within a year of that or so, as more and more companies started to roll out Kubernetes, they started to recognize a real need for strong guardrails, strong safeguards in their clusters, and admission control is the way you do that. And so OPA was like a good fit, and it just kind of grew from there. So yeah, so that's sort of like the background on Kubernetes. I guess the other thing you're asking is like how we like perceive, I guess, use cases versus integrations. Is that kind of the question? Yeah. So we I mean, I guess we typically look at integrations in like a couple different ways. One way is just how you integrate OPA into your software to enforce the policy, right? So like the question that most people have when they come to OPA is like, how do I express the policy? And the answer to that is Rego. You write Rego that codifies your policy as code, and then you can execute it and run it. Then the next question becomes, well, how do I actually get my policy enforced in my software, whether it's Kubernetes or my microservices or whatever? Right. And the answer to that is you integrate OPA. So you basically go into your software, like your service, basically, and you query OPA whenever you need to make a policy decision. And then the decision comes back from OPA, and your software then interprets it and enforces it. So if OPA says allow, then you allow the request and you process it normally. If it says deny, then you send an error back to the client and tell them that they can't do what they're trying to do. So that's sort of like one type of integration, is where you're just integrating OPA into some software in order to enforce policies using OPA. But there are other kinds of integrations, and the other kind, like the main other one we see are more of like sort of administration or kind of management integrations, and typically that comes in the form of like how you get I guess policies into OPA, which we have kind of like a standard API for doing, but also how you get data into OPA, because a lot of the time the policy decisions that you make need kind of additional information. They need context from the state of the world in order to render a decision. So like so that information has to basically make its way into OPA, and so we'll see people building kind of integrations with OPA that pull data in from some source and then load it into OPA so that it can be used by the policy engine or by the policies, by the rules at decision time. And so yeah, that's like what the kube management project that we created a long time ago for OPA kind of does. Is it helps get data about the state of the cluster into OPA so that you can write policies over that, which opens up a lot of really cool applications and use cases. So then use cases are just like problems that people have that they want to solve that are policy related, right? Like how do I control access to this API using a role-based model or an IAM style model, or how do I take this like list of 100 different network policy rules that I need to enforce on all kind of like workloads to get deployed, and then how do I actually get those enforced automatically, right? If you're talking about like a large financial firm, like they will literally have hundreds of rules that they need to check against every single workload that gets deployed. And so it's like, is the workload exposing telnet? Is it like, is it trying to connect to a box in China? Like, is it, it's just like, they just have all these different rules based on all kinds of different things. And in the past, they would just do it all manually, right? And it would take 6 months to get workloads deployed. But now with like self-service platforms, that obviously doesn't work, and you need a way to codify those rules, and OPA does that. So yeah.
For sure. Yeah, I like the way you described that. You basically have your policy, which you're writing in Rego, and then you have basically whatever evaluates that and then sends the decision back to the system, which in Kubernetes is the admission controllers there. One thing I wanted to point out for some folks, just some nice tools, is there's a Rego playground. So you can basically, if you ever use like the Go playground or anything like that, you can basically write your policies here in the browser and evaluate them. So earlier I was submitting some Kubernetes objects and having the policies evaluate them. So this is a really handy tool. Tor and I were talking about before we came on sort of the like intricacies of Rego. And one of the things that immediately came to mind for me, and something that we've kind of explored when talking about different templating and that sort of thing we would do with CrossPlane. What was the decision like to decide to sort of build a DSL for expressing policy? Was there any thought of, using any existing system, or, having them written in a lower level language or something like that? Or did you think that Rego was kind of a necessity for making the project successful?
Yeah, so yeah, I guess the background of the language is that some of the one of the other co-creator, Tim Henricks, has a deep background in some of these technologies, and we looked at it, but we tried a bunch of other things actually, and like one of the things we tried was like using like SQL to express policy, and that, I mean, it's a query language. Rego is a query language essentially, and so it kind of works. But if you try to apply SQL to any kind of like deeply nested like hierarchical data, then you end up having a pretty bad time. And so we did some tests. Some tests were done with Azure, for example, where we were trying to write similar kinds of policies over Azure API or Azure data. And you ended up having to like write joins over like dozens of tables in order to like just express a simple policy. So there were just kind of like fundamental limitations with that we felt were kind of like showstoppers. And then like in terms of leveraging a kind of a more standard like imperative language, you could do that. I guess what you'd end up probably sacrificing is a few things. You know, obviously you're going to sacrifice performance because you know, traditional programming languages will sort of take they will do a lot of work to give you like micro optimizations, right? So they'll make it really fast to like, you know, add two numbers together. But what they won't do is do any kind of like global optimization. That's sort of like left up to the developer, right? So if you want to like look up some value, you have to decide like, how am I going to look that up? Am I going to use a list? Am I going to use a hash table? Am I going to use a tree? Right? And then you're you know, and that's just like standard programming. But the problem is that as a policy author, you shouldn't really be thinking about any of that, right? As you're writing down these rules, you just want to look at the compliance spec or doc or whatever, and you want to just like ideally take those rules and plonk them down into code, right? And a lot of the times those rules are just basically if-then statements. And so you know, they say this like allowed this request if, you know, the user is connecting from a corporate device and they're multi-factor auth and they're in the right region and blah, 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 right? It's just like an if-then statement with a bunch of conditions. And so that's what these sort of like some of these rule languages are really good at expressing. And so we took some inspiration from existing an existing language called Datalog and added a few interesting things on top of it, like ability to you know, dereference or search and analyze large kind of or like deeply nested JSON data structures. So that's sort of what we focused on initially, was making it really easy to write policy over these sort of nested data structures, because those are what you find like everywhere, right? Every modern API is returning, whether it's JSON or something else, it's probably hierarchically structured. It's not just like a flat set of tables, and so when you're writing policy, you need something that can accommodate that. We also looked at like, well, maybe you don't need to, maybe you can get away with having a language that's totally flat and doesn't have this sort of support for deeply nested data. But then the problem is that sort of shifts the burden onto the integrator to like do a data transformation right before they load the information into OPA. So like if, you know, and if we'd gone that route, I don't think the Kubernetes use case would have been nearly successful, because for every single resource, you would have had to write a transformation that like flattens out that data and loads it into the engine. So that would have been, I think, kind of a showstopper, because we wouldn't even be able to do this thing that we're talking about here today, right? Like you would have had to go off and write a whole bunch of data transformations for your CrossPlane types, and so that would have just been a bit of a buzzkill. So I think over time, like, you know, creating a language is obviously not like an easy task. It's not something that we'd recommend people just like embark upon. But you know, so we spent a lot of time obviously building out docs, but as well as tooling and other things to help people ramp up and be successful. And so, yeah, I mean, I think there's still tons of work to do, but we're pretty happy with it today, I think.
Definitely. Yeah. And from my personal experience, so like you see kind of programmers wanting to write their own specific languages frequently, and a lot of times it's not needed. In this case, I found when I was experimenting with OPA and kind of integrating it with CrossPlane, that this was really powerful. It has a lot of ability, yet it's still a pretty simple language. And you can kind of start with really simple evaluations, right? Like, does this value equal this? If not, then it's a violation. And then kind of expand on that to write more complex policies. So I thought it was really well done. So I'm excited to show off some of the functionality that it provides when doing things with CrossPlane. One thing that you mentioned, and we're going to start getting into the demos here real shortly because we're already about halfway through our time, is that there are kind of two different ways to deploy OPA in Kubernetes. One of them is through this kind of kube management strategy, which is using, as y'all call it here, kind of like plain OPA, and then using this sidecar container. So we're going to look at this real quickly. So you see here, there's deploying with plain OPA right here with queue management, and we also mentioned OPA Gatekeeper. We're going to talk about that later on. But first, we're going to look at queue management. So this is kind of a nice architecture diagram that shows you how to, or what the structure of this looks like in a Kubernetes cluster. And you can see that these policies here look a lot like they do for any of the other integrations that you'd see as well. They've got these deny policies, as well as some of these other stanzas. So we're going to look at doing that real quickly. So while I'm doing this, Torin, if there's anything you want to mention about kind of what's going on behind the scenes, then please feel free to do so. For everyone watching right now, all of these manifests and any of the code is always available in the TBS repo in the CrossPlane org. So there's actually a PR open to put this stuff up there right now. Then after the show, of course, we will have it available. But starting out here, we are going to, and I'll make this a bit bigger here so that folks at home can see. That's probably large enough there. We're going to start off by just creating a kind cluster running locally here. And the next step we're going to do is install CrossPlane. So we'll just go ahead and have the operators running there, and we'll install the GCP provider for some of the infrastructure that we're going to provision and place policy on using OPA. So what I'm doing here is basically just getting the latest master of CrossPlane, and then you'll see that I'm also installing the GCP provider here, and we should be good to go with that. Wanted to also give a shout out to a couple more folks in the chat here. We have Sebastian, who is also joining from France. Thanks for joining. Charles, who is joining from San Francisco. No, Charles, he works on Linkerd, and he has some awesome live streams as well. So check out his stuff. And then Gaurav, who is from India, and he's been doing some work on the CrossPlane project. So really appreciate y'all tuning in here. So it looks like our kind cluster is ready. So I'll go ahead and install CrossPlane here. Once again, if you're interested in what's happening here, I'll point you to the docs or any of the previous shows. But you'll see here that we've installed the latest version of CrossPlane. If we check out what pods are running here, we should see, I'll just check out the CrossPlane system ones. We should see that the CrossPlane controller as well as the CrossPlane stack manager is running. And then you'll see we're unpackaging provider GCP here. And shortly we should see that the provider GCP controller is coming up. So what's happening here is we're just installing our different CRDs that represent the GCP types. There you'll see the GCP controller coming up, which is going to watch for those types that we've installed when we create, delete, and update them, which is also similar to some of the things that OPA does, especially Gatekeeper is a controller as well. So we'll see some kind of synergies here with how that works. But we should be able to look and see that our custom resource definitions here, you'll see that we have our core CrossPlane ones as well as some GCP ones. So it looks like everything is installed successfully. So like I said, we're going to start off with plain OPA as it's referred to on the website. So deploying it as admission controllers. And so we have to set up some of this TLS manually to be able to talk to the API server. I've actually already done this, but these commands are pulled right from the OPA docs. So you can do that there. I've already created these, as you can see, but follow along if you'd like to. All we need to do is go ahead and create our OPA namespace. And before we do that, I'm actually going to go ahead and put my GCP credentials into the cluster to make sure that if we provision any resources that we can connect to GCP. We'll create our OPA namespace and our secret, which is going to be used for TLS, you'll see there.
And this is just the this is just what allows the API server to talk to OPA securely over TLS. So I think with a lot of, like, we wrote this this tutorial a long time ago before there were any like frameworks to help you build admission controllers. And so we wanted to show people, like, this is how you can bootstrap it the hard way, you know, from just using basic kubectl stuff and command line tools. And so that's why we're doing all this like certificate generation and so on. It's just to give people kind of visibility into like how it actually works.
Definitely.
So yeah.
Yeah, and if anyone has questions about why you need to do that, why you need to set up certificates, the Kubernetes docs are really helpful for that. So you can take a look at admission controllers there. The next thing that we're going to do is actually create the deployment of the admission controller. So I've actually gone ahead and just copied this into a file here. You can also pull this from the OPA docs. But what you're seeing is we're setting up some RBAC for the controller. We're setting up a service. And then in deployment here, we have the OPA container as well as the kube management container. I'm going to let Torin talk about this a little bit, but you'll see here that I have these lines commented out here. We actually don't need them right now, but this is to basically register these types with the cache. And Torin, would you talk a little bit about, while I'm creating this, why you might want to do that and what kind of additional policies enables you to do if you do replicate these types?
Yeah, for sure. So I guess the thing to keep in mind is that like OPA just basically answers questions whenever your software like needs to make a decision, right? So the API server is asking OPA for admission review decisions, and OPA is evaluating the policies and whatever information it has, whatever data it has cached to make those decisions and to send it back to the API server. But something needs to like load the policies into OPA. Something needs to distribute the policies or the data to OPA that are going to be needed. It's going to be needed by the policy engine. And so that's what this kube management sidecar does. That was sort of like it was a very quick project that we put together that's seen quite a bit of use in production. So it's fairly battle tested. It's a very actually small amount of code. I think it's only like a couple hundred lines of Go code, and all it really does is it'll if you configure it to, it'll watch for config maps that contain policies, Rego files, and it'll replicate those into OPA. And then whenever the config maps change, it'll replicate them in. So that gives you a way to load policies into OPA via Kubernetes. So if you're a Kubernetes administrator, you're probably really comfortable provisioning Kubernetes resources. And so we figured if you want to load policies in, well, it would be nice to just do it through the Kubernetes API. So that's the first function that it provides. The second function it provides is that kube management can also be configured to watch arbitrary Kubernetes resources. So you can configure it to watch pods or deployments or services or even CRD, even custom resources like the CrossPlane resources. And what it'll do is it'll replicate those resources into OPA. And then OPA will keep those resources cached in memory. So kube management is basically just sitting there doing a bunch of list watch, following the sort of list watch pattern that like every controller on the planet does. And it's just copying data from out of the API server, out of etcd, out of the API server into OPA, so that data can be referenced within the policy without having to go fetch it on every single like decision, right? So the OPA's basically got like a warm cache of the cluster state, and that cache now allows OPA, or allows you as a user of OPA to implement some pretty interesting policies, because you can write a policy now that makes a decision about some incoming resource that's being created by a user or a CI/CD pipeline or something like that, based on the state of the cluster. So while it is eventually consistent, it's pretty powerful. So like, for example, one of the tutorial we have on the website shows how you can prevent conflicting ingress resources from being created, because with some ingress controllers, there's a problem which is that if you create two ingresses in two different namespaces that overlap, like they share the same host or the same host prefix or same path prefix, then you'll accidentally get traffic potentially redirected to the wrong namespace, right? So if you have a dev and a prod namespace and a dev and a prod ingress, you can shoot yourself in the foot pretty badly there. And this is actually like brought down like pretty big systems because people just accidentally configured like an ingress in their dev namespace, and then accidentally had prod traffic hitting some development load. So you want to prevent that from happening. But like from Kubernetes point of view, from the controller's point of view, it's not necessarily like wrong. It's just like it's a standard kind of thing you might see in networking, but like operationally, it's not something that you might want. And so you can put a policy in place that says, check if the ingress that's being created conflicts or overlaps with any of the existing ingresses in the cluster, by essentially writing a policy that iterates or searches across the state of the cluster that's cached inside of OPA to decide whether or not the ingress can be created. So having the ability to kind of have this like eventually consistent in-memory cache that the policies can reference is pretty powerful. And we kind of generally refer to that kind of information as context. And this is just like one of those kind of integrations that we talk about, where kube management is providing this kind of management functionality, right? It's loading policies into OPA, it's loading data into OPA. And so yeah, so that's what kube management does.
Yeah, for sure. So I think that that's a really good point. Also, when we look at some of the policies that I've written for this demo, we can see kind of how we get some of that functionality if you can compare them to other ones. So the policies we're going to show off today are specifically looking at objects that are, some operation is happening on, which we don't have to cache them or anything to be able to see those. But if we wanted to write something, as Torin was saying, where we were comparing an object to existing instances of that same type of object, then it would be useful to have those cached. So quickly here, I'm going to go ahead and register our webhook here. You'll see that we're actually using the certificate that we generated, and then we'll create it. Once again, this is just another step in provisioning this on Kubernetes. So I will go ahead and create that. And the next thing that we'll do is label the kube system and OPA namespaces here, which is basically just saying with these webhook ignore things that we don't want OPA to act on those. And I think in the configuration, and Torin, correct me if I'm wrong, I think that we mentioned that it is webhook ignore, or is it just automatically configured to evaluate for the label?
Yeah, so the way this works is like when you have the validating webhook that you were showing a second ago, it's outside of the deployment YAML. It's in the tutorial, or it's in the notes that you have.
Oh, gotcha.
That webhook configuration that you got right there, yeah. What it's basically saying is send all create update operations on all resources, because it's like every type of wildcard resources, wildcard API groups, and so on. Send all of that to OPA. But in some cases, you don't want to have Kubernetes consulting OPA for admission control decisions. Like you may or may not want to have it do that for like kube system, because that's got like cluster components in it. And if the policy decides to, stop Kubernetes from like spinning up a pod that's part of the control plane, then obviously that's not great. So you can inside the webhook config, you can restrict which resources basically get sent, and you can do that using different things. You can do it with rules that match the operation or the resource type, as well as with like label selectors on the namespace. So like in this case, we're just labeling the kube system namespace to ignore the webhook, and then also the open namespace. Like you don't want the webhook being applied to itself, right? So because that would create a cycle, and that's not good. So you want to kind of restrict that. So that's one way of doing it, and that's what we show here.
Yeah, for sure. And, another thing, for instance, if you're using CrossPlane, it may make sense to, for instance, label the CrossPlane system namespace. So anything that's kind of that system level thing where maybe a controller is creating objects that you wouldn't want, applying policy to those. Generally, most of the policy, at least that we're going to show today, is for, people who are actually creating objects and that sort of thing. So just keep that in mind whenever you are deploying an admission controller. So next thing we're going to do is actually create a policy. So as Torin mentioned, this config map that's created in the OPA namespace is going to basically load this policy into OPA. So let's take a quick look at what this looks like. Another thing I want to shout out real quickly is that Torin has built a VS Code plugin, which is super nice for writing Rego policies. So definitely download that if you're writing any of this. It has some cool stuff where you can actually do some testing and simulation and that sort of thing. So that is a giant help. You'll see that this policy here looks similar to some of the ones we saw on the documentation. It's a pretty simple policy. Basically, we're just saying, check if it is the Cloud SQL instance kind that's being created, and then get the size off this field that is in a Cloud SQL instance. So if we hop over and look at an example of a Cloud SQL instance, we're basically just going down into this nested data structure and looking at data this size GB. So obviously this would only apply to Cloud SQL instances because it's a specific schema. And we're saying if that size is greater than 20, we don't want to allow folks to create it. So maybe that's a cost control. Maybe that's just some policy we want for our GCP environment. And then we're going to let them know also why it's rejected so that they can take remedial action to make sure to get their resource provisioned correctly. We also have this package statement up here, which you're going to see across a number of the different policies that we write. Torin, can you talk about how packages work in Rego and sort of especially what this Kubernetes admission one does?
Yeah, sure. So all of the rules that you write in Rego, and in this case, deny is a rule. All of the rules that you write are namespaced, and they're namespaced inside of like a hierarchical space. So the package is what declares that namespace, and so that means that you can have basically like different groups of people contributing policy from different namespaces, and then you can aggregate those together. So like in the tutorial example, or in this example, we just put all the rules in the Kubernetes admission namespace. But you could, in theory, have like policies for in different namespaces. Like you might have a namespace for compute-related policies and storage-related policies, or you might have or you might do it instead of based on domain, more based on organizational structure. So you might have like your infrastructure team or something like that, contribute a set of policies, and those would come from the infrastructure package. And then, app level policies would come from the app level policy package. So the packages give you a way of like namespacing policies, and then inside your rules, you can refer to policy or other rules in other packages, and that allows you to do kind of composition and delegation of decision making inside the language. And so there's nothing special about Kubernetes.admission in terms of OPA. Like OPA doesn't even really know what that means. It just knows that there's a namespace called Kubernetes.admission. It doesn't know anything about Kubernetes or admission. It just knows that it's a two-level namespace. And then there's actually like another special policy that's like the main function essentially, which you'll see which if you look in the deployment file, the admission control deployment file, you'll see in there at the very bottom, there's like there it is. It's a package in package systems, which is a convention in OPA where basically if you don't ask for a specific decision, it'll generate the decision with name system.main. And so in this case, what we're actually doing in this special bit of boilerplate here is constructing the actual admission review response that gets sent back to the API server. Right. Gotcha. So that's not code that's like written inside of OPA or anything like that. It's all just handled inside of the policy here. And what we end up doing is basically like importing the admission package and then grabbing all the values that are in that deny set and packaging them up into an error message and sending them back. So this was just kind of like how we got OPA integrated with Kubernetes in the beginning. And it was kind of cool because like we didn't have to change OPA in any way, right? We just give it a policy that kind of tells it what to generate. And it just kind of worked. So that was pretty cool at the time. Yeah. And this also illustrates like the kind of non-Boolean nature of policy or non-Boolean capability inside of OPA policies. Like when you write an OPA policy, you'll see lots of allows and denies. Those are actually not meaningful to OPA. They're not like built into OPA in any way. They're just kind of like they're just variables essentially. And so like in this case, deny is a set. We're adding error messages into that set. In the other case, in the main case, main is just an object that we've defined. So you can actually generate these like non-Boolean policy decisions, which has interesting applications, right? Like a lot of policy systems will just let you say like allow or deny, and allow and deny are built in, and like you can't change that, you can't extend that. But with OPA, there's nothing really stopping you from doing that. And so yeah, that's kind of neat. Like in the case of Kubernetes admission, you can do like mutating policies as well. So you can generate like mutations that get sent back to the API server to get applied. So if you want to like rewrite container images to stick the SHA in, or you want to stick a node selector on a workload or something like that to make it easier for developers to deploy apps on your platform, then like mutating policies are one way of doing that. And yeah, it's kind of neat. It just falls out of some of the design decisions in OPA. So yeah, definitely.
That's super cool. That's actually a lot of that is not stuff I realized just from the initial reading of the documentation, that sort of thing. So that's really helpful to know. And that gives me a lot of ideas about kind of how you said, like composing different policies and that sort of thing. So definitely, we might have to have you on again to do some more complex policies after this. But as we showed just a moment ago, we created a config map with our policy in it to deny the creation of Cloud SQL instances with size larger than 20. So let's look here. We have a Cloud SQL invalid. These are cluster scoped objects, so namespace really isn't important here, and it's looking at the cluster scope. So this has a data disk size of 30, and the valid one is of 10. So we should see that when we create this Cloud SQL instance at the cluster scope with 30 gigs, that it is going to say you're not allowed to do that and give us information about what the policy is. So let's go ahead and try that out here and make sure it acts as expected. So that's in plain Cloud SQL invalid. And we'll see here. So database size of 30 is larger than the limit of 20. And it also tells a little bit, just about how you can correct that. And that's one of the things that's really nice about this is that you can kind of do this formatting. Hold on, I lost my editor here for a moment. In the policy, and say things like, you provided this value here of 30 and it needs to be at 20. You'll see later on how this can become even more powerful when we look at constraint templates when using Gatekeeper. But just to show briefly that you can create one that's smaller than that, let's try and create a valid Cloud SQL instance. Once again, this is static provisioning, so we're creating these resources directly. So they're being evaluated at creation time here. And if we create that, we'll see that it did get created. And let's just make sure that that's actually provisioning on GCP here. Looks like it actually is not, which might be a different configuration. It's because I'm using a resource name. This is actually, if anyone is a CrossPlane user on this call, this is something that is really annoying about Cloud SQL on GCP, is that you can't use a name for like a month after you've used it once and deleted it, which is very frustrating. But if you're doing dynamic provisioning, we generate the name for you. So that shouldn't be a huge issue. But just to kind of show that this works, let's call it Big DB TBS 14. This is actually a small kind of DB, relatively. So we'll go ahead and rename that. So let's try again to create that, just to show that it will be provisioned. Let's see here. Plain Cloud SQL valid. And let's check and make sure that this does work here. Yep, so we'll see it's pending create. After a little while, we will see this database instance come available, and it can be used and consumed by an application at that point. Now we also want to see what it looks like when you dynamically provision, right? So this policy is on Cloud SQL instances, which you don't actually create yourself when you do dynamic provisioning. You create a class, and then you create a claim that can be scheduled to that class. Here you'll see we're doing it with this TBS 14 label. So since this is the only Cloud SQL class that's going to be created, and it has this TBS episode 14 label, then our claim should be scheduled to that. You'll also see that our class here is too large for the constraint. We should not be able to create a Cloud SQL instance. So this is an interesting use case because when the claim is created and it's scheduled to this class, CrossPlane is actually going to create a Cloud SQL instance. But because that is a separate object and this policy still applies to it, let's see what happens when we do this kind of dynamic provisioning case here. So I'm going to go ahead and create the Cloud SQL class that is invalid, which, like I said, is going to be successful because this is not a Cloud SQL instance. We could also have a different policy or maybe evaluate the same policy for Cloud SQL instance classes if we didn't even want to have that configuration in the cluster. But we're just doing it on the instance here. And then let's create our MySQL claim. All right, so that was created successfully, which is also expected. But if you look and see when we get this MySQL claim, we should see that there's no resource kind and no resource name here. And if we actually look for Cloud SQL instances in the cluster, we should only see the one that was created earlier via static provisioning with the valid example. And if you want to see why this actually happened, because we kind of surfaced the reason or the status of the created resource to the claim, that abstract request for it, we can actually see here that same error that's returned from the admission webhook. So CrossPlane is basically saying, hey, I saw that you created a claim for a database and you were scheduled to this class. I went and tried to create it for you, but there's a constraint that's not letting me. So it's nice to see here that you can do that same kind of thing, with dynamic or static provisioning, and you still get that kind of feedback about it. And that kind of makes sense too, right? That you're not denied from creating a request for your infrastructure, but that request just isn't being satisfied. On the other hand, in static provisioning, you're actually directly creating it, and it will not let you do that. So I'll go ahead and clean up this claim here. And now we are going to go on and look at Gatekeeper, which is in my opinion, the right way to do this on Kubernetes, and it's a lot simpler, especially of a deployment model. So I'm actually going to go ahead and we'll just do this on a completely new cluster. So let me check how that Cloud SQL instance is doing, see if it's still provisioning. Let's see if we can just clean this up actually, and I'll clean that up in a moment. So I'm going to go ahead and get rid of this cluster. And let's create a new one. So once again, we are going to deploy CrossPlane into the cluster. And then instead of doing the setup of the admission controller, we're actually going to just deploy Gatekeeper, which is OPA's Kubernetes native controller here. So let me go ahead and get this provision. While I'm setting up CrossPlane again, Torin, do you want to talk a little bit about what Gatekeeper is and how it operates a little bit different than what we just showed?
Yeah, for sure. So yeah, so like as we saw, you can take OPA and you can deploy it just natively on top of Kubernetes. And then you need to kind of like figure out how you're going to get policies into it. And you could do that by volume mounting or with kube management or using bundles. But those aren't really what I guess you'd say is like Kubernetes native ways of managing the admission controller, right? And so what Gatekeeper provides is kind of like a first-class integration between OPA and Kubernetes. And so what that means concretely is that you can manage policies as CRDs. So your policies are loaded into Kubernetes as CRDs. They're called constraint templates, and those get replicated into OPA. And then on top of that, it adds a way to do parameterized instantiation of policies, which is a complicated way of saying like you can define a policy that accepts parameters, and then you can instantiate that policy with some parameters. So like in the example you gave about the size limitation, you could have a policy that accepts a limit size, like a max number of bytes or something, or max gigabyte size as a parameter, and then you can instantiate constraints of that type supplying the parameter, right? So that way the administrator doesn't have to write policy necessarily. They can just instantiate a predefined policy and give it some configuration. And so this is just a kind of a way of encapsulating some of the policy logic into kind of like reusable chunks. And it's all done with Rego. So like you can take all of the policies that you write and evaluate them offline or in your environment. It doesn't change anything like that. It's all Rego under the hood, but it adds this kind of like Kubernetes native opinionated way of structuring those policies. So that's one thing it does, is it gives this parameterized library to users. The other thing that Gatekeeper does above and beyond OPA is that it provides an audit controller. So OPA is just a policy engine. It just answers queries whenever you make them. But when those queries are run and what they're run for is up to you as the integrator, as the caller. And so like in this case, what we've seen so far is that OPA is being run as an admission controller, and it's being queried to get admission review decisions whenever API requests are coming into the API server. But what you might also want to do is ask the question of your policy engine, like what resources in the cluster currently violate these policies, right? And so you might have policies that are not being enforced, that are just being monitored for various reasons, and you might want to have those executed against the state of the cluster. And so Gatekeeper has an audit controller that basically will periodically run the policies against the state of the cluster and then generate audit reports. And so that's useful from an audit point of view, obviously, but then it's also useful from like a rollout perspective, because you can sort of start off with your policies in an audit read-only kind of mode, and then have a monitoring only mode, and then have them like gain some confidence that they're doing the right thing, and then roll them out into enforcing. So that's sort of that's what Gatekeeper really brings, I think, on top of FOPA, is this sort of first-class Kubernetes integration, and then some nice additional functionality like auditing, parameterized library of policies, as well as some like dry run capabilities and so on. So lots of like goodies for people that are operating Kubernetes at scale and that want to have OPA rolled out.
Definitely. That's a great description. And you'll see while Torin was talking, I actually went ahead and installed Gatekeeper. It's super easy. You can see the controllers up here and running in the Gatekeeper system. And then we already have all that functionality that he was mentioning right out of the box. Unfortunately, we only have an hour today. Or actually, we're going to have a little more than an hour So we're not going to be able to go through all the different things that Torin mentioned there. But there is a lot of different powerful features in Gatekeeper. We are just going to show the constraints and constraint templates today, 2 different examples of that. So the first one here is just basically translating our DB size policy that we used in the last example to the kind of Kubernetes native feeling with constraint templates and constraints. So you'll see here, this looks very similar. We're looking for a Cloud SQL instance, once again, making sure that the size is not over a specific value. But you'll see that we're actually passing that in as a parameter. So we can use this constraint template and create multiple constraints that are for different sizes. This is obviously not super customizable, but it does say you can create a lot of different constraints for different sizes. And the other thing that's really powerful about that is that you can match this to different kinds, namespaces, different other selectors, and that sort of thing. So I could say, in app1 namespace, the size limitation for Cloud SQL databases is 20. And in app2, the limitation is 50 or something like that. So you can really specialize that to different namespaces. And you'll see when we create this constraint template that we're actually defining a new kind in it. So this will look very similar to kind of like a simplified CRD that we have right here. So what Gatekeeper is going to do is actually create a CRD in our cluster that we're defining here, this Cloud SQL size. And then when we create this constraint, it's going to use the schema we define and allow us to create instances of that Cloud SQL size. So let's go ahead and apply the constraint template first, which once again is going to give us the ability to create these Cloud SQL size instances. So we've created that, and then we now should be able to just create the constraint because that Cloud SQL size CRD is created in our cluster. And you'll see that that is successful. We created this Cloud SQL size 21 where we're passing in the parameter of size 20. So once again, if we try and create statically that invalid Cloud SQL instance, then we should see that we are unable to. So once again, we see this response here. You'll see that the parameter that we pass in of 20 is now reflected in the error message. So if we wanted to, once again, make another one that was specific to a certain namespace or something like that, then it would be picked up by that policy. So this is kind of just a different way of doing what we already did with a little more flexibility. But now I want to show something that is a lot more powerful, especially when working with CrossPlane. So this other constraint template here is basically saying for all objects that are created, if they have this field, which all of our claim types do, this class selector match labels field, which determines how it's scheduled, then we want to restrict the labels it can define there. So as I mentioned earlier, on our classes here, we can put labels and then match claims to them using that. So within your organization, you could have a schema of like DB large or DB small labels. And then when someone creates a request, an abstract request for a database where they say, I want a MySQL instance, I'm agnostic about what actually satisfies that behind the scenes, they can just say things like large or small. They don't have to specify their actual number for the size of the database. So we're going to see here that in the constraint template, we allow you to define some labels that are available. And then when we create an actual constraint for that, we're specifying the kind here that we want it to match for. So for this instance of this claim scheduling constraint, we only want to look at MySQL instances, and we only want it to apply to the default namespace. So if we created a MySQL instance claim in a separate namespace, then this policy would not be applied. And then with the schema that we defined in the constraint template here, we're basically allowed to specify rules that we want to be valid or not here. So let's say we'll do DB large here. And I'm going to go ahead and create this constraint template, which once again is going to allow us to create instances of the constraint. So this is constraint template app. So that was successful. And then we will create the actual constraint itself. So we'll see DB no large here. And so basically what we're saying is that if we create a MySQL instance in the default namespace, which that was actually a very poor name for it, DB no large, because we're actually saying it must have the large label, but you get the idea. If we create a MySQL instance in the default namespace and it does not have this label on it, then it should fail to create. So before we were saying we create the claim and then CrossPlane fails to create the actual Cloud SQL instance. Here we're saying you can't create a claim that would be scheduled to this configuration at all. So you can kind of get two layers of policy here. So you'll see on this claim, we do not have the DB large matched labels here. So if we try and create it, and it doesn't have a namespace, so it'll be in the default namespace. Let's try and see what happens. So you'll see here, we used a class selector label, TBS episode 14, that's not permitted. And then we're also returning the ones that are permitted. So once again, using those parameter values that we passed in the actual constraint itself, these labels, and then putting those in the error message so that the user is able to really easily identify what went wrong and then correct it. And if we modify, or actually I'll just show creating it in a different namespace. So this actually isn't going to be scheduled to anything because we haven't created the class, but you'll just see that you can actually create this successfully without it being rejected by the policy. So this is not in the default namespace, so this policy should not apply. And there we see it successfully created. So this is the kind of the power of defining a very simple constraint template that applies to lots of different things. This is especially useful in CrossPlane for values that are defined by interfaces in our structs that the CRDs are generated from, because every claim is required to have these fields and stanza for scheduling. So any of those like system level mechanisms, you can go ahead and create policies that can then be pass parameters to apply to them. So this is really powerful. You can see how this allows you to create fine-grained controls on all of your cluster. And there's a lot of different things that Torin was mentioning, like doing dry runs and that sort of thing, which even expand this functionality further, or doing audits, which evaluate things that are already created in the cluster. Like I said, we won't get into that too much just because we're a little time constrained. I did want to do one kind of fun demo here before we finish up. So if you've watched TBS before, you're probably familiar that you can actually create resources in remote clusters and spin up new remote clusters. And so I wanted to show how you can actually use CrossPlane to deploy Gatekeeper into a remote cluster. And then you can actually create constraints in that cluster. So you get kind of this hierarchical policy engine here. So first thing I want to do is create the actual Kubernetes cluster. So we're going to spin it up dynamically. So we have a GKE cluster class and then a claim for that. And this is going to take some time to come up here. So we can see what this looks like as the cluster is actually being provisioned. So you'll see here it's in the provisioning state. It's using that config that we just created. So while I'm waiting for this to come up, which will take some time, Torin, is there anything else you kind of wanted to touch on specifically around using Open Policy Agent with CrossPlane or Kubernetes in general, or some functionality that you've kind of noticed through this demo where you think OPA would be really valuable to CrossPlane?
No, I mean, I think you've done an awesome job of like showing OPA off and CrossPlane and how the two kind of play together. I think that I really like the label example that you just went through, because I think like labels are obviously so core inside of Kubernetes that you know, even if like everybody should start off with a good label strategy. Like they should figure out what labels they want to use, but then once they've done that, they need a way to ensure that they are being used properly. And so I think that that's one area where OPA and Gatekeeper really shine. And it shows up here in CrossPlane, so that's super cool. And yeah, I'm kind of now I need to think a little bit more about how like we could use this for deployment of OPA across a number of clusters, because this is definitely definitely an interesting use case. So yeah, no, this has been great. I think that, you know, what what this really highlights also is like how the Kubernetes, API server and the model around just like declaring the intent for your infrastructure and data declaratively opens up a lot of cool stuff like these kinds of like multi-cloud deployments, as well as for policy, right? Because now you have a single place where you can enforce policy across, workloads, compute workloads.
After creating a constraint there that basically says pods in the default namespace must have this gatekeeper label. And we'll see, this is kind of also a demonstration of showing that the state of the resource in the remote cluster is propagated back to the control cluster, and you can see why it wasn't created successfully and that sort of thing. So it is a pretty interesting use case. And it looks like that our GK cluster is now ready. So that was pretty quick. One thing you should notice is that we should see a secret with the kubeconfig connection information now available in the default namespace. So you'll see the K8s cluster secret there. If we looked at it, it would have the data there as the kubeconfig. And then we can also see that there's a Kubernetes target, which can be used for scheduling here. So you'll see it's actually just has the UID of the Kubernetes cluster that we created, the claim. So now if we create Kubernetes applications in the default namespace, they can be provisioned into that remote cluster. So the first thing we want to do is deploy Gatekeeper into that remote cluster. So we're going to use that same command, except for we're basically going to get the content and use this kubectl CrossPlane pat command, which is now officially released. We showed it on the Linkerd episode, showing deploying Linkerd into some remote clusters. But basically, we're just going to pipe that to the pat command, which is going to wrap that in a Kubernetes application. And then it will be scheduled to the remote cluster. So let's go ahead and give that a try. All right, so you'll see the Kubernetes application was created. If we get our Kubernetes applications in the default namespace, we should see that, oops, get Kubernetes applications, you'll see it's partially submitted. So 2 out of the 12 desired resources. So if I think I pulled it up earlier, if we actually looked back at the content here, there's 14 resources here. And they're just getting wrapped up in the Kubernetes application being sent to that remote cluster, or 12 resources, excuse me. And we should see that these eventually are successfully deployed. And if you want to look at each of the individual resources reflected in the control cluster, we can get that and see that they're submitted. It looks like all of them were submitted successfully. Let me move this real quick. And you can see the types. So we're creating some custom resource definitions, let the configs and constraint templates and that sort of thing. And so now Gatekeeper is running in this remote cluster, which means that we can now create instances of the CRDs that we created in the remote cluster, like the constraint template, and apply those. So let's do that quickly as well. And one thing I like about this pat command is that you can actually just use the exact same templates we used earlier and just wrap them with this command, as opposed to actually packaging them yourself into a wrapping Kubernetes application. So as you can see here, we're just gonna pipe the contents of this constraint template, which I think I took this basically verbatim from the Gatekeeper docs here, but it's basically requiring labels on pods here. Or it might be on, let's see, it's on any type. So we're saying it's a pod in our constraint, but let's go ahead and create the constraint template. And we can, once again, let's get our Kubernetes application resources, and we'll grep for constraint. So you'll see here, constraint template was created. It was submitted successfully. So now we've defined, or Gatekeeper in the remote cluster has now created this, we've created this constraint template, which has now led to the creation of a CRD, which represents actually implementations of that constraint. So we can now create this K8s required labels object in the remote cluster. We actually wouldn't be able to create this in our control cluster here because we have not defined it as a constraint template. So let's make sure that this gets created successfully. All right, so it looks good. and constraint template. And so we want to look at, I think it was Kate's. So you'll see this case required labels. It looks like it was also successfully created in the remote cluster. So now if we try to schedule pods in the remote cluster, we should get denial if they don't have that Gatekeeper namespace or the Gatekeeper label on them. So let's hop back over here. So you'll see we're going to take this pod and try and schedule it to the remote cluster. You'll see it does not have the Gatekeeper label on it, so it should fail here. And we'll see how that's reflected back in CrossPlane. Do this real quick so we can see a little more. All right. So it was successfully created, and let's see, we'll look for pod here. So you'll see it's in the failed state. And if we actually get the Kubernetes application resource itself and look at the status of it, we should see here that that violation of policy in the remote cluster happened. And you'll see that we need to have this policy or this label Gatekeeper on our pods that we create in the remote cluster. So, you know, it may be that you want to define all of your policy at the control cluster level, but this is kind of a handy way, especially if you're doing sort of like a cluster as cattle kind of policy. You can imagine that you could immediately spin up a new cluster and then apply all of your defined policies in that cluster, since they are just defined as Kubernetes resources. So we're about 15 minutes over. So Torin, I appreciate you hanging with me here. But I think this has been a really awesome episode. We ran through a lot of different things. So we're probably going to need to have some sort of write-up to follow up on this to give people some more comment. And I hope to also get some documentation out so we can show how to use these together even better. But I really appreciate you joining on this show. I think it was really helpful, and I'm looking forward to some future integration with the two projects.
Yeah, no, thanks for inviting me, Dan. And yeah, I see a future with lots of blog posts and possibly other streams down the road. So yeah, we'll definitely chat more about this stuff.
Definitely. Sounds good. Well, cool. I won't hold you any longer. I appreciate everyone joining on the stream. It looks like we had a good number of folks on today. And we had a lot of fun, so I hope you did too. And with that, everyone have a good rest of your week.
Take care all. Bye.